All right, here we go. Some more binomial expansion. So we're still chapter 3.5, excuse me, the binomial theorem. Let's quickly review binomial theorem. There's another whole video on this. It's intro to binomial theorem, but we basically have x plus y to some nth power is equal to the sum of the nth upper bound, where I is the lower bound, n choose I times x to the n minus I times y to the ith power. Where does this all come from? It comes from the Pascal's triangle, where, and recall that n choose I is in your calculator. It's under the math probability. You can use your calculator to find those values, or you can use the binomial coefficient, longhand, to do it there. N is the power of the binomial, and I is a specific term that you might be looking for, or a specific value that you're looking for. Remember Pascal's triangle. This is n equals 0, n equals 1, n equals 2. N choose 0, it's the 0th term, first term, second term, third term. How many terms are in an expansion? Well, it's n plus 1 gives you the total number of terms. All right, so again, this is to the power of 3, but look, 1, 2, 3, 4 terms. So there you go. Okay, quick explanation. I know if you want to have more information on that, you can get more. So let's see. We are, sorry about that. Drop you on the floor. Okay, number 1, find the coefficient of b to the 6th. Given the expansion of 2b squared minus 1 over b all to the 12th power. So what do? All right, well, it's 12 choose I times our x, which is 2b squared, and then n minus I, we know n is 12, times negative b, now this little figure with a b with a line through it, it's to separate it so we know it's not a 6, okay, to the ith power. So what do we want? We want that exponent to equal 6. So we set it up to, we take the inner power here, 2, because we're dealing with all the b's now, 2 times 12 minus I, minus, right, here's minus 1, so minus I equals 6. We distribute, you get 24 minus 2i minus another i is equal to 6. 24 minus 3i is equal to 6, and you find out that I is equal to 6. What do? We plug that back in. See how important it is not to make sure you delineate between your b's and your 6's, because it could get you in trouble someday. So here we go. 12 choose 6. Times 2b squared all to the 6th power. How do we get to 6? Well, we went back up here. 12 minus 6 is 6. Negative b to the first to the ith power, and I is 6. So with that, you get 924 times 64 b to the 12th times b to the negative 6th, and you get 59,136 b to the 6th power. All right. Example number 4. Example number 4. So let's take a look. It says, given the expansion 2 times the quantity, or 2 over x squared minus x all to the 15th power. All right. Wow, really active today. Okay. So what all right, what do? Well, first it says find the number of terms in the expansion. If you recall from our discussion over there, the number of terms is equal to n plus 1 is the number of terms. So we have 15. 15 plus 1, so 15 plus 1 is equal to 16 terms in our total expansion. 16. Now, we have it says find the constant term. So we're going to find the constant term. It's 15 choose I times 2x to the negative 2 because this x squared was in the denominator. So we change it to a negative exponent. It makes our life a little easier. To the 15 minus I power, n minus I. And then we have just an x to the ith power. All right? So then we want x to have a 0 exponent. So we distribute negative 2 times the 15 minus I plus the I that we have here is equal to 0. Well, when is all that equal to 0? When we distribute negative 2, we get negative 30. Negative 2 times negative I is positive 2I plus an I equals 0. 2I and one more I makes 3 I's. We add 30 to the other side, and I is equal to 10. Okay, so now that we have that, 15 choose 10 is multiplied by 2 times x to the negative 2, all to the 5th power. How do we get that? 15 minus 10, which is 5. Then x to the ith power, so the 10th power. And when we multiply, 15 choose 10 is 3003 times 2 to the 5th, which is 32. X to the negative 10 times x to the positive 10, so that way our x's will go away. We can simply do that. And we are left with 96,096 as a final result. All right, so there you have it. That's a fourth example for you. Good luck with these problems. They're a lot of fun. Just remember that when you work with I and the binomial coefficient, I know you'll get it. That's cheesy. Okay, bye. Have a great night.